show that the joint probability density function of y1, y2, so on, yn given by g bracket starts y1, y2, so on, y1 is equal to curly bracket starts n factorial into f y1, f y2, so on, f yn, where a is less than y is less than a is less than y1 is less than y2, and so on, yn is less than b equals to 0 elsewhere. We shall prove this result for the case of n3, but the argument is seen to be entirely general. When n is equal to 3, the joint probability density function of x1, x2 and x3 is equal to f of x1 into f of x2 into f of x3. Let us consider the probability such as probability of bracket starts a less than x1 equals to x2 is less than x less than b, where a is less than x3 is less than b bracket close. The probability is given by integral a to b integral x2 to x2 f of x1 x2 f of x3 d of x1 d of x2 dx3 is equal to 0. Since integral x2 to x2 f of x1 dx1 is 0, now without altering the distribution of x1, x2, x3, we define the joint probability density function of f of x1, f of x2, f of x3 to be 0 at all the points of x1, x2 and x3 that we have at least two of their coordinates equal. The set A where f of x1 into f of x2 into f of x3 is greater than 0 is the union of 6 mutually disjoint sets as follows: A curly bracket starts x1 comma x2 comma x3 bracket close, such that a is less than x1 is less than x2 is less than x3 is less than b curly bracket close. A2 is equal to curly bracket starts x1 x2 x3 bracket close, such that a is less than x2 minus x is less than x1 is less than x3 is less than b curly bracket close. A3 is equal to curly bracket starts x1 x2 x3 bracket close, such that a is less than x1 is less than x3 is less than x2 is less than b curly bracket close. A4 is equal to curly bracket starts x1 x2 x3 bracket close, such that a is less than x2 is less than x3 is less than x1 is less than b curly bracket close. A5 is equal to curly bracket starts x1 x2 x3, such that x is less than x3 is less than x1 is less than x2 is less than b curly bracket close. A6 is equal to curly bracket starts x1 comma x2 x3, such that x3 less than x2 is less than x1 x less than b curly bracket close. In all the 6 cases, first case the third element x3 is same. We will alter x1 and x2 in these two equations, and third and fourth middle one terms containing x3 and altering x1 and x2 in first and last term. So and the last fifth and sixth we have x3 in the first place, and altering second and third place x1 and x2. There are 6 of these sets are x1 x2 and x3 can be arranged in 3 factorial ways, 6 ways. Let us consider the function y1 is the minimum for x1 x2 x3, y2 is equal to middle of magnitude of x1 x2 x3, and y3 is equal to maximum of x1 x2 x3. These functions defined one-to-one transformations that map each of a1 a2 and a6 onto same sets. So beta is equal to curly bracket b is equal to curly bracket starts y1 comma y2 comma y3 bracket close, such that a is less than y1 is less than y2 is less than y3 is less than b curly bracket close. And the inverse function are the points of a1 x1 equal to y1, x2 equal to y2, x3 equal to y3, and for points a2 x1 equal to y2 and x2 equal to y1, x3 equal to y3, and so for each of the remaining four sets. Then we have j1 is equal to 1 0 0, determinant of 0 1 0 and 0 0 1 is equal to 1, and j2 is equal to determinant of 0 1 0 1 0 0 0 0 1 equal to -1, and so on. Thus the absolute value of the sets of 6 Jacobi is +1. Thus the joint probability of the density function of the three order statics is y1 is equal to minimum of x1 x2 x3, and y2 is equal to middle one of magnitude of x1 x2 x3, and so on. Y3 is equal to maximum of x1 x2 x3. So g of y1 y2 y3 is equal to modulus of j1 modulus of j1 f of y1 f of y2 f3 y3 plus modulus of j2 f of y2 f of y1 f of y3 plus so on, modulus of j6 f of y3 y2 y1 0 is less than y1 is y2 is less than y3 is less than b, so which is equal to 3 factorial f of y1 f of y2 f of y3 is less than y1 is less than y2 is less than y3 is less than b, 0 elsewhere where n is equal to 3.